so in this video, short video, we will cover only limit. Okay, so let fz limit continuity in the next video later. So let fz be a single valued function. Okay, single valued function. All right, then what happens? Defined in S domain. Okay, defined in domain D. Okay, which includes neighborhood of a z is equal to z0. What do you mean by that? Like I have explained in the next video. This. All right. Now, fz may or may not be defined at this z is equal to z0. So there, for a given small real number, so you have been given this small real number. There exists a real number del is equal to greater than 0. So I repeat again, for a given epsilon greater than 0, there exists a del greater than 0 where this fz whose limit is L should be less than del. Sorry, less than epsilon. Okay, less than epsilon. Okay, so in the neighborhood of z minus z0. But this is too difficult decision. So this will be true whenever, I hope you are able to see, whenever mod of z minus z0 less than del. Okay, maybe in the deleted neighborhood, because at z is equal to z0 it is not defined. Okay, so if this limit exists, then you can conclude one thing: it is unique at z is equal to z0. Which limit I am talking about? If z tend to z0, fz, if this limit exists, this value is unique. Now, if it is unique, then as z goes to z0, what happens? Value of the limit should not depend on any path. Okay, how will you check? Let's say this is the region or domain for this. This is x-axis, this is y-axis. Then from z tending to z0, or it just shows direction. Either you go from this path or this path or this path, value of limit should be same. Okay, either you go through segment wise, so it should be path independent. Okay, if we obtain two different limit as z tends to z0 along two different path, say this one and this one, if you obtain different limits, then the value of limit does not exist. Okay, this is going to be very handy in finding out the continuity and limit values. Okay, so let me tell you a theorem where if fz is uxy plus I vxy, right? Then for z is equal to x plus iy, what is z0? Z0 is at x0 comma y0. Then what would be limit? Limit would be u0 plus I v0. Okay, basically you can what it means is you can find limit of this and limit of this separately, u and v, and just put like this. It would be a limit of fz, a function, right? Another remark: if fz has a finite limit at z0, then fz is a bounded function in some neighborhood. Okay, I have told you in the definition of the limit itself, fz minus L should be less than epsilon whenever this is true, z minus z0 in the deleted neighborhood. Okay, so if limit exists, then fz would be bounded for sure. Okay, and what is the limit at z is equal to infinite? If somebody says find the limit at z is equal to infinite, what will you do? Replace z by 1 upon zeta and find limit z tends to infinite, fz is equal to limit zeta tend to 0 f of 1 upon zeta. You have to find limit of that. Okay, I hope you can see there. Fine, in the next video we'll continue with the continuity. Okay, so next video we'll continue with the concept of continuity, differentiability. Okay, so thank you so much, and do subscribe to the channel. Thank you.